Hi, boys and girls. Today we're doing Chapter 13, Lesson 10, Problem Solving. Draw a diagram. So our learning intention is I am learning to draw a diagram so that I can solve real-world problems. So let's look at the pages that we're going to be working on today. You'll need to have your math books out for pages 811, 812, and 813. There's no independent practice. We'll be doing all of this together, and I expect you to watch the entire video and fill in your pages exactly the way I do, because this will help you be a better problem solver. So let's look at page 811 first. Okay, so our essential question is, how are perimeter and area related, and how are they different? And that's part of what we're trying to learn with all this perimeter and area stuff, is the difference between them and the ways that they're similar. Okay, so let's look at the first strategy, or look at this strategy. It's one strategy. So Chloe's father is building a rectangular sandbox. It has a width of 4 feet and a length of 6 feet. The wood that goes around the sandbox costs $2 for each foot. If they had $50, would that be enough to buy the wood? Now, when I finish reading this, I go, whoa, that is a whole lot of information. And if I'm a third grader who's not ready to go to fourth grade, I would go, let's see. I see a 4 and I see a 6. I'm going to add those together. That's 10. Oh, there's a 2, so I'm going to add that. That's 12. Oh, look, and a 50. So 50 and 12, whip out my fingers. 62. There's my answer, 62. Oh, I see dollar signs. Okay, we'll make it dollars, $62. But third graders who are ready for fourth grade will go the longer way around and figure out what the real answer is so they can get it right. So we're going to do a 3-read with this word problem. So remember that a 3-read, the first time you read it, you are reading it without any numbers and without the question. Now, one important thing about this word problem, the question is 1/2 of a sentence. So it says, if they have $50, will that be enough to buy the wood? So everything from the comma on, we're going to cross out just temporarily, because that part is the question. Will that be enough to buy the wood? Okay, we need the $50 to help us solve the problem, so we don't want to cross that out. Okay, so back to what we were doing, our 3 reads. So the first one, we're not going to read the question. We're not going to read any of the numbers. We're going to say the word some, S-O-M-E, in place of the numbers. So I'm going to go ahead and read it. Read along with me, and when we get to a number, you're going to say some. Okay, Chloe's father is building a rectangular sandbox. It has a width of some feet and a length of some feet. The wood that goes around the sandbox costs some dollars for each foot. If they have some dollars, we're done right there. I know it doesn't make sense, but that's fine. It will in a minute. So now I'm going to imagine what's going on in this word problem. So I see a sandbox, and I see that it is longer on one side than on the other because it's a rectangle. And I'm at Home Depot and I'm looking at wood for my sandbox, and I see there's a price tag there. And I look in my hands and I have some cash in there in my hands to pay for this wood. So now I'm going to read it again, and I'm going to put all the numbers back, but still no question. Chloe's father is building a rectangular sandbox. It has a width of 4 feet and a length of 6 feet. The wood that goes around the sandbox costs $2 for each foot. If they have $50, now I'm going to adjust the picture in my head. So I see a rectangle that on the short side is 4 feet, on the long side is 6 feet. And when I go to Home Depot, I look at the wood I want, and I look at the price, and it says $2 a foot. And then I look in my hand to see how much money I have, and I see I have $50 there to pay for it with. Now I'm going to read it with the question. So I'm going to go ahead and erase the question, or erase the line over the question. Sorry, not erasing the question. It's printed in our book. Okay, let's read the whole thing. Chloe's father is building a rectangular sandbox. It has a width of 4 feet and a length of 6 feet. The wood that goes around the sandbox costs $2 for each foot. If they have $50, will that be enough money to buy the wood? So I can tell from the question that my answer is going to be yes or no. So if I'm not ready for fourth grade, I'll just pick an answer. Yes or pick no. But I won't know if I'm right or not. I'll be taking my chances. It's better that you figure it out, and you have a much better chance of getting it right. So let's work on the first step. Understand, what facts do you know? Okay, so the sandbox is blank feet by 6 feet. So I'm going to look up here at my sentence about the size of the sandbox, and it has a width. Oops, that was not a marker. I'm a highlighter. Let's try that again. And I'm not going to pick yellow, I decided. I'll pick pink because that's not anywhere else on the page. Okay, so it has a width of 4 feet and a length of 6 feet. So I'm going to put that information into my blanks. The sandbox is 4 feet. No, that's yellow. That's not going to work. Come on. Be nice if I could work things, right? Okay, the sandbox is 4 feet by 6 feet. The wood costs $2. You can see that up here. $2 for each foot, and they have $50. So the wood costs $2 for each foot, and they have $50. What do you need to find? Is $50 enough to buy the wood? So I can draw a diagram to solve the problem. That's going to be my plan. I already know what my facts are, and really we did that when we did the 3-read, but then this is another way to do it, to just actually write this stuff out. Okay, when you take the state test, there's a highlighter feature in the hamburger bars. You can use the highlighter, and then you can write things on your scratch paper, and I highly encourage that. You should be using your scratch paper for every single problem on the state math test because it is hard and you'll need to write it. Okay, so I can draw a diagram to solve the problem, so that's what I'm going to do. I'm going to come down here to number 3, and here you can see they drew a diagram. So here's the sandbox. The perimeter is 6 feet by 4 feet by 6 feet by 4 feet. So it's 6 plus 4 plus 6 plus 4, or, now remember when we watched perimeter on Brain Pop, we learned to make long addition problems shorter, make it easier. 6 plus 4 is 10. 6 plus 4 is 10. 10 plus 10 is 20. Okay, now you're going to multiply the perimeter by the cost per foot, because if it's per foot, that means this foot is $2, this foot is $2, this foot is $2, and you're adding $2 20 times, or also known as multiplication. So we're going to multiply the 20 feet that it is around by $2. So 20 times 2, 20 plus 20 is 40. So it is $40. And since $40 is less than $50, they will have enough money. Okay, so let's see if my answer is reasonable, and we're going to explain it. So let's think of this problem in another way. Let's say that we put the money amounts for each of the sides and then add it together. So since it's $2 per foot, if we multiply 6 times 2, that's 12. 4 times 2 equals 8. Okay, and this over here would be the same. So this would be 8 feet, and this would be 12 feet. 12 plus 8 is 20. 2 plus 8 is 10. Put down the 0, carry the 1 to the tens place. 1 and 1 is 2. So that's 20. And then I have 8 and 12 again. So 20 plus 20 is equal to 40. So I came out with the same amount of money that I had in the other one. So I know that my answer is probably correct. So let me scroll here. What's going on? Okay, my screen is frozen. Great. So I think I solved the problem with the screen. So the question is my answer reasonable? And we're going to say yes. And the reason is we came up with the same answer twice. There we go, finally. Yes, comma, because when it says explain, you're going to use comma because I came up with the same answer 2 times. You can pause the video here if you need a little bit more time to type that in. For the rest of you, let's move on to the next page. Okay, so let's look at a picture frame. So here we go. A picture frame is 2 inches longer and 2 inches wider than the photo shown. What is the perimeter of the frame? So let's do a 3-read with this. A picture frame is some inches longer and some inches wider than the photo shown. So I'm imagining, I see the picture and then I'm thinking, the frame is bigger, which is true of frames, bigger than what the picture is. So we need to find out by how much. So a picture frame is 2 inches longer and 2 inches wider than the photo shown. So what do they want us to do with that information? Let's read the whole thing. A picture frame is 2 inches longer and 2 inches wider than the photo shown. What is the perimeter of the frame? So I need to figure out the perimeter of a rectangle that is bigger than the picture that is there. So what facts do we know? So let's do some highlighting and then we'll write it in here. So we know that the frame is 2 inches longer and 2 inches wider than this and this. Okay, so let's write that in there. The frame is 2 inches longer than the 4-inch side and 2 inches longer than the 6-inch side of the picture. Okay, so that's what we know. Okay, let's scroll down and see what we can do with that. Oh, what do we need to find? Well, we need to find the perimeter of the frame, and we can highlight that to help us. We need to know the perimeter of the frame. So we'll type that down here. I need to know the perimeter of the frame. Okay, so my plan is that I'm going to draw a diagram because that's what we're learning how to do. I will draw a diagram. Sorry for yawning. I'm tired. It's late. Okay, and so now I'm going to solve it. So I'm going to draw a diagram of the frame. So first I'm going to make a rectangle. Okay, oops, that's white. That's not going to help us much. We'll go with red. Okay, here's my frame. Okay, and I know that the short length on this picture is 4 and the long length is 6. So I'm going to call this 2 plus 4 and 2 plus 6. So it's 2 inches longer than 6 and 2 inches longer than 4. So 2 plus 4 is 6 and 2 plus 6 is 8. So I'm going to put these numbers on the other side because opposite sides of a rectangle are equal. Then I'm going to write my number sentence, 8 plus 6, plus 8 plus 6. I'm going to make it simple. 8 plus 6 is 14. 8 plus 6 is 14. If I add them together, I can do it in my head. 10 and 10 is 20. And 4 plus 4 is 8, so it's 28. So it is 28 inches. Okay. Let's scroll down. Okay, is my answer reasonable? Well, let's figure it out. So if I can figure out this perimeter here. I know that 6 plus 4 is 10, and this would be 6 plus 4 is 10. So 10, okay, why is it not writing now? 10 plus 10, because I'm off the page, equals 20, but I'm not done because I added 2 to each side. So I'm going to do it in a different color. So if there's 2 here, and 2 here, 2 here, and 2 here, 2, 4, 6, 8, 20 plus 8 is 28. So I tried a different way to solve it to see if I got the same answer, and I did. So, is my answer reasonable? Going to say yes, because I got the same answer 2 times. Okay, there you go. All right, and you can pause the video to finish writing this stuff in, or finish typing, and then go on to the next page. For the rest of you, we're going on to the next page. Okay, so let's go on to the last page. We're going to do this together. I expect you to do everything that I do. So we're going to do a 3-read. Phil cut a piece of yellow yarn that was some feet long. Kendra cut a piece of red yarn that was some feet shorter. William cut a piece of green yarn that was some feet longer than the piece Kendra cut. All right, so everybody's got a piece of yarn, different colors, different lengths. So Phil cut a piece of yellow yarn that was 7 feet long. Kendra cut a piece of red yarn that was 2 feet shorter. William cut a piece of green yarn that was 3 feet longer than the piece Kendra cut. How long was the piece of yarn that William cut? Sorry, still yawning. Okay, so, oops, you know what I did? I went ahead and read the question. Okay, so Phil has yellow yarn that's 7 feet. Kendra has a piece of red yarn that's 2 feet shorter, which means we're going to have to subtract. And William cut a piece of green yarn that was 3 feet longer, which means we're going to have to add, than Kendra cut. So how long was the piece of yarn that William cut? So I'm going to go ahead and draw 3 pieces of yarn. So we need a yellow piece of yarn. We need a red piece of yarn that is shorter. And we need a green piece of yarn that is longer than the red yarn. And it's probably going to be longer than the yellow yarn too, because the red yarn is 2 feet shorter than the yellow one, but the green one is 3 feet longer than the red one. So it's probably going to be the longest of all. But that's just a guess. Let's find out. So we know that Phil has a piece of yarn that's 7 feet long. We know that Kendra's yarn is 2 feet shorter. So hers is 7 minus 2. And whatever Williams is, it's the red yarn. Let's use the variable R, red yarn plus 3. Okay, so let's start doing some math. So 7 minus 2 we know is 5. So Kendra's yarn is 5 feet. And if Kendra's yarn is 5 feet, then 5 plus 3 equals 8 feet. Now, the question is, how long was a piece of yarn that William cut? Well, William has the green piece of yarn, so William's yarn is 8 feet. There we go. See, it's a lot easier when you break it down. So it sounds like a really hard problem till you break it down. Okay, Lisetta is planting flowers around the outside edge of her rectangular garden. The garden is 12 feet long and 10 feet wide. Oops, sorry, no numbers. The garden is some feet long and some feet wide. She will place some flower at each corner, and the remaining flowers will be placed some feet apart. How many flowers will she plant? Okay, oops, I read the question. Man, I need to focus. It's late, so I'm losing my focus. Okay, so pretend we didn't read the question. All right, so here's the word problem again. So she's got a rectangular garden, and it's one side is longer than the other, or two sides are longer than the other two. And we know she's going to place a flower at each corner, and then she's placing flowers at some amount of space apart. Okay, so let's go ahead and read it now with the numbers. So Lisetta is planting flowers around the outside edge of her rectangular garden. The garden is 12 feet long and 10 feet wide. She will place one flower at each corner, and the remaining flowers will be placed 2 feet apart. Okay, so her garden has two sides that are 12 feet and two sides that are 10 feet. Okay, she's going to, at each corner, she'll have a flower, and then every 2 feet, she's going to place another flower. The question then is, let's read it with the question. Lisetta is planting flowers around the outside edge of her rectangular garden. The garden is 12 feet long and 10 feet wide. She will place one flower at each corner, and the remaining flowers will be placed 2 feet apart. How many flowers will she plant? Okay, so first we're going to draw a diagram. So we're going to draw a rectangle. And we know that this rectangle is 12 feet this way and 10 feet this way. I'm going to make red dots for the flowers. So she puts a flower at each corner. That's kind of small, isn't it? Let me make it a little thicker so you can see it better. There we go. There we go. All right, then she's going to plant them 2 feet apart. So if this flower on the corner is at 0, I'm going to count by 2s and plant a flower till I get to the other corner, which should be 12. So 0, 2, 4, 6, 8, 10, 12. Ooh, those are pretty evenly spaced. Not too shabby if I do say so myself. Okay, then if this flower is 0, 2, 4, 6, 8, 10. If this flower is 0, we go 2, 4, 6, 8, 10. Oops, I was off that time. The one in the corner is 12. And then if this one is 0, 2, 4, 6, 8, 10. Now all we have to do is count the flowers. So we will start with, let me use blue. We'll start here at that one. Wow, that was thick and just obliterated it. Let me make it thinner. There we go. Okay, so that's 0, 1, 2, 3. Wait, that's 1. 1, 2, 3, 4, 5, 6. This one on the corner is 6. 7, 8, 9, 10, 11, 12. This one is 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. The last one is 22. So all I did was count around. I'm not adding anything up. Okay, so she will plant 22 flowers. Okay, I added this clip in because, let's just do undo. Because I had done it wrong. And so I wanted to put it in to make sure that you guys had the right answer and the correct diagram. This one was really hard to understand, and the third grade teacher is mad about it because I wasn't the only one that had difficulty with it, and we found the correct solution. So that's why this looks like awkward and like it doesn't fit, because it doesn't. I redid it. Okay, community center is organizing a dance. There are 4 large columns arranged at the corners of a square. The decorating committee will hang one large streamer from each column to every other column. how many streamers are needed. Okay, I didn't bother with the three-peat on this one because this one's hard to understand, even if you do the three-peat. So what messed me up was they'll hang one large streamer from each column to every other column. And it didn't make sense to me at first. I came up with the solution, but then it was the wrong answer when I double checked it. But one of the other third grade teachers got the correct answer and she knew how to do it. So this is what we're going to do right now. But what I want you to learn from this is that you're not going to be able to do every single word problem that you're given accurately, but you should try your best. And so you do what you think is right and hope for the best on the ones that are confusing. I will say that I don't like the word problems in this book very frequently because they are confusing. So anyway, so we do know that there are 4 large columns arranged at the corners of a square. So I'm going to draw a square. And you need to draw this as well. And then there are 4 large columns, like those Roman columns that you see in fancy places. So we're going to put one at each corner. Okay, then we're going to hang one streamer from each column to every other column. So I'm going to pick a streamer color, and we'll use orange. So I'm going to hang a streamer from this column to this column, and this column to this column, this column to this column, this column to this column, and then we need to make sure that we go across. So it's every other column, like each of the other columns. So now we're going to count the streamers. Let me pick a counting color. We'll pick green because we haven't used that yet. So we have 1, 2, 3, 4. This one that goes this way is 5, and the one that goes diagonally the other way is 6. So we used 6 streamers. This shows you the importance of drawing a diagram because there is no real mathematical way, that's easy at least, to figure that out. You have to draw a picture for it. So that's the point of this lesson, is that you draw a picture. So again, we went from this column to this column, that was 1. We went from this column to this column, that was 2. We went from this column to this column, that was 3. Then we strung from this column to this column, that was 4. Then we went across on the diagonal, so that's 5 and 6. And I did them opposite, but anyway, it still comes out to 6 streamers. Last one. A cafeteria table has a length of some feet and a width of some feet. If some tables are pushed together, that's the end of it, because the rest of it is my question. Okay? So now let's read it with, so I have these cafeteria tables, okay, and I'm going to push them together, some of them together, okay? So let's go ahead and read it with the numbers. A cafeteria table has a length of 8 feet and a width of 3 feet. If 3 tables are pushed together, okay, so I know the size of my tables, they're 8 by 3s, and I'm going to push 3 of them together, okay? Then I'm going to read it with the question now. A cafeteria table has a length of 8 feet and a width of 3 feet. If 3 tables are pushed together, what is the combined area of the table? So I know I need area. So I'm going to draw these 3 tables, 8 by 3, 8 by 3, and 8 by 3. So this side is 3, this side is 3, this side is 3. The long sides are 8. So the area of one table is 3 times 8, which is 24. And I have 3 tables that are the same size. Now, I don't know how to do double-digit multiplication. If your adult wants to show you, that's fine. But we know how to do repeated addition. So we're going to do that and add them up. Okay, 4 plus 4 is 8, plus 4 more is 12. I also know that 3 times 4 is 12. So I'm going to put down the 2. I'm going to carry the 1 to the tens place. So 2, 4, 6 plus 1 more is 7. So it's 72. Now I'm doing area. So remember, area is measured in square. And then the measurement, which is feet. 72 square feet. There you go. Get all that done and turn it in, and you're good to go.